bar on my pad, so it's one of the right up there with email. It's that important. So, highly recommended. All right, so it's just a little news update. We start these with some of the latest things going on in astronomy, and we're going to stay in the solar system this month. We're going to look at Ultima Thule again. I did a little news update on them recently, and as you'll see, there's a little trickle of data coming down from New Horizons, giving us a little more information all the time about this very, very distant Kuiper Belt object. And then we'll take a look at and say goodbye to Curiosity. So, Ultima Thule is being observed, or was observed by the New Horizons mission. It launched in 2006. Where was everybody in 2006? Came up to Pluto 2015. Yeah, don't answer that. Hey, I'm having microphone problems. I'll just hold it. And the mission has been extended through 2021. And it went on to this little rock, or two rocks, called Ultima Thule. Here are the first images. This is two images shifted a little bit with two little colors. So if you did bring your 3D glasses, you can take a look at it and get a kind of an image of that. But what's come down since our last update is this image. This is the highest spatial resolution image. This is taken by New Horizons again. It made its closest approach on January 1st of this year. And each little pixel dot on there is about 110 feet. So pretty big boulders, if you could see a boulder there. But these are two rocks that are just kissing. They didn't really smash into each other. They kind of did this. They went bump and are sticking together. Now they look pretty round, don't they? They look really like two big snowman Olaf-like balls put together. There's another processed image of that.
John, how far away is this?
I'll show you. Oh, I got numbers on that. So, I did. No, I hid the numbers. I don't have that memorized. I'm sorry.
Well, in billions, I mean, 2 billion miles, 3 billion miles.
Oh, any idea?
I'll look it up.
You look up. He'll look up the real number. I don't want to mislead. So, another image that they've downloaded from the spacecraft is from behind. And the behind image has given us a different picture of the Ultima Thule system, that it may not be two balls touching, but it may be kind of two pancake pillow things touching. We don't know really how thick they are vertically like that, but it's a little different image. Now, what's really strange is we can't really figure out how two things could come together and be stable that look like that. So the planetary scientists are getting to think more about that. Do you have a number?
I'm getting there.
Oh, he's getting there. Okay, stretch. So again, we're getting less than a kilobyte per second, 800 bits per second, coming down from New Horizons. And the data download is going to go through September 2020. So we'll get more images and more information as time goes on. 20 months to download the images that were taken.
So as luck would have it, it's giving it to me in astronomical units.
Okay.
Roughly 45 astronomical units.
45 astronomical units. So,
We'll do the quick math on that way.
all right, thank you. For the New Horizons future, they do want to go on to find another object, but looking at the data that came from Pluto, we're seeing that there are a lot fewer little things in the outer solar system than we thought. So here's a close-up of the moon Charon around Pluto, and look how kind of featureless it is. You got some big things that hit and some medium things that hit, but there's a real lack of the tiny little craters you'd expect. And so, for some reason that we have yet to figure out, the Kuiper Belt is more devoid of or empty of the little rocks that we would expect. So that's another interesting finding from New Horizons. They think that they can keep this thing alive through the 2030s, and they're looking for a third thing to go to. And once they're done trying to get to look at new Kuiper Belt objects, they plan to look back and take the most distant image ever taken of Earth. But the Earth is so close to the sun that they very well might fry the camera doing this little trick. So they don't want to do it before trying to find something else to fly by in the outer solar system. All right, and our next little item is saying goodbye to Opportunity. Opportunity was operational on Mars for 15 years. This little rover going around and taking data and images. It went silent when our big dust storm hit 9 months ago. They kept trying to reestablish communication with it, and it has not come back. So that on February 13th, NASA declared it mission complete. I guess that's better than saying it died. So that would make everybody sad. But the last image before the dust storm hit is what I'm going to show you next. So a little goodbye picture from the rover. This is made up of 354 separate images taken from May to June of last year. So here's the central image. That is really neat.
That's a nice deck that it's got there.
Nice, yeah. Can you build a summer home here? So let's go from left to right, and these, I believe, are the very last images. I think I had to take multiple images of filters to get the color, so I didn't get to complete this little part. And then you got some tabular rocks here. Here's the image we just saw. This is where Opportunity entered this little valley, Perseverance Valley. Got some pitted rocks down here. Here's a little bit of its own solar panel. Here's the crater rim of Endeavour crater. And then going over here, got a little hill, and here's the tracks that it made driving in, right there, and part of its antenna. So, bye-bye Opportunity, and that's it. Now we're going to switch gears here and switch technology over, and we'll get our main speaker up and going.
It was 4.2 million miles, 4.2 billion.
4.2 billion miles out. Thank you. I didn't have that stored in my brain. So. All right. Turn the big knob.
No, this thing stopped working.
Oh, you're kidding. Switch over to game.
Wait, yeah, so there was a robot named Opportunity?
Yes, there was. Let's see if I can do better with the microphone on me than I did on myself.
Can I exit?
No, he's taking care of it. It's all going from his pad.
Put it on there maybe?
Sure, just stick it in.
Whatever.
Right, test, test, test.
Test, test, test.
Yep. You're in.
Hang on, we're
Okay,
getting
we're
hooked up here.
switching.
Yep, there it goes. All right. All right, sorry for that little delay. There's one more chair here that's not being used by me. If somebody wants a chair here, please grab it. I'm going to go stand over here in the light. So, wow, what a turnout. This is great. It's going to be a great night. It's clear out there. You're going to see lots of nice stuff after these talks. My name is Bill Tschumy. I'm a volunteer here at the Lowell Thomson Observatory. As Mike has said, I'm also one of the authors of an astronomy app. Currently the president of the Longmont Astronomical Society. As you can see here, I'm going to give a little talk on the introduction to the night sky, particularly as related to observational astronomy. That means looking through eyepieces at things. And if you've read the little blurb that was handed out about my talk, you'll see that I consider observational astronomy an intellectual endeavor. It's a lot of the things we look at are little faint smudges in the eyepiece. And you say, well, it's a little faint smudge. What's so important about that? But when you really learn that faint smudge is a galaxy that's 13 million light years away, and it's 50,000 light years in diameter, then all of a sudden you realize, oh, that's really cool. I'm looking at this little faint smudge. because it's taken 50 million years for that light to travel all this way and hit your eyeball tonight. So what I'm going to try to do tonight is to help you understand some of the stuff you'll see through the eyepiece and appreciate it more. When I do observational astronomy, I always think of the 5 W's, the who, what, when, where, and why. It's used in journalism and investigative reporting, things like that. And I always think, well, who? Okay, so what is this object? What's its name? What am I looking at? What is it? What kind of object is it? Is it a star cluster? Is it a, asteroid? When? When was it formed? How old is it? And where is it in our solar system or in our galaxy or even in the universe? And then why is it there? How did it get formed? So if you think of those 5 W's, when you're looking at something, it really helps you understand what it is you're going for. So let me give a brief overview first of what we're going to talk about. And I'll also say, please feel free to stop me, raise your hand, ask questions. This all looks very organized and things, but it just help me keep track of what I'm doing. First, we're going to talk about astronomical distances and sizes. Then we'll talk about what are called shallow sky objects. These are things in our solar system. So the moon, the planets, things like that. Then we'll go off to deep sky objects, star clusters, nebulae, other galaxies. We'll talk a little bit about our own galaxy that we're embedded in, our Milky Way galaxy. And then talk about equipment. So if you get inspired by this and you say, gee, I want to get some equipment and start looking at the sky. Talk a little about that. And then finally, how to get involved in this hobby. What some resources, things you can do to help kind of learn about this. So, astronomical distances. So the first thing, fundamental unit we're going to talk about is the light year. And light is the distance light year is the distance light travels in 1 year. And as you know, light's really fast. It's 186,000 miles per second is how fast light travels. And that means that a light year is approximately 6 trillion miles. And that gives you an idea why we even use the term light year. 6 trillion is this number that's so huge you can't conceive of it. Yeah?
Why do stars move? Why does light move so fast?
That's a great question. I don't think the best physicists actually know the answer to that, why light moves that fast. They're still trying to figure that out. No, it's fine. It's fine. So anyway, 6 trillion miles. And again, the only thing you talk about when you talk about trillion is our national debt or something like that. And otherwise you don't use trillion because there's nothing that big. So anyway, we sort of take that 6 trillion miles and we collapse it down and call it a light year, because then we can sort of talk about smaller numbers of things. In the same way you can talk about light years, you can talk about light minutes. It's the distance light travels in a minute. And Earth is about 8.5 light minutes from the sun, which happens to be about 93 million miles. Pluto is about 5 light hours away from us, out near the edge of our, sort of on the edge of our solar system. Solar system really goes a little further than that, but we think of it as the edge. So the nearest star to us, Alpha Centauri, is about 4.3 light years away from us. So right there you sort of see, wow, stars are way farther away than Pluto is. We're talking about 5 light hours out to Pluto, but you're going out to almost 5 years out to the nearest star, other than our sun. Stars are much further out than the planets are. So a consequence of the fact that light travels, even though it's very fast, it does take time to travel and things. When you look at objects that are really far away, you're looking back in time. So when you're looking at that, well, say you're looking at the sun, I said it was 8.5 light minutes away. When you look at the sun right now, you're looking at what the sun looked like 8.5 minutes ago, because that's when the light left the sun, and it's been flying through space for that 8.5 minutes and just hitting your eye now. Likewise, if you look at a galaxy that's 13 million light years away, you're looking at light that left that galaxy 13 million years ago, and it's just now getting to us today. So you're seeing what it looked like 13 million years ago. And we always have somebody who says, well, that means that object you're looking at may not exist anymore. So if you're looking at a star, Betelgeuse, for example, that's about 50 light years away from us, that star may have blown up or not be there anymore, but we still see it. because the light from that explosion hasn't gotten here yet. It'll take 50 years for that to get here. So telescopes are time machines. When you use them, you get to look back in time. I'm going to grab my water here real quick. I had a salty dinner. Great. So let's talk about astronomical sizes. We talked about distance a little bit. So here's a little series of slides I'll show you. Some people may have seen this on the internet. They went around a few years ago. And let's see if I can find my pointer that's in one of these pockets here. There it is. So here are the sort of the inner planets along with Pluto. And so as you can see from here, Earth and Venus are about the same size. Mars about half the diameter of the Earth. Little Mercury maybe 3/5 the size, or excuse me, about 2/5 the size. Little Pluto about the quarter the size of the Earth. However, the other planets, much bigger. Look how big Jupiter is compared to our Earth. You can take about 11 Earths and line them up across the face of Jupiter. Jupiter's 11 times the size of Earth, and Earth's pretty big. Earth has a diameter of about 8,000 miles in diameter, and Jupiter's about 11 times that big in diameter. Saturn, not quite so much, maybe 9 times the diameter of Earth, and then Uranus and Neptune. But there's the sun compared to our planets. The sun is huge. Look at how big it is. I mean, there's Earth right there. You can take 100 Earths and line them up across the face of the sun. The sun is monstrous compared to our planets, even compared to Jupiter. Well, is the sun the biggest star? No. There's our sun. Got Sirius, that's the brightest star in the night sky. Pollux in the constellation Gemini we'll see tonight. And big old Arcturus. Boy, Arcturus is huge. Is it the biggest star? No. There's Arcturus. Rigel, Aldebaran, Antares, and there's Betelgeuse. That's the one I said is going to explode. Betelgeuse is huge. Betelgeuse, if you put it where our sun is, would extend out to about the orbit of Jupiter. It's this monstrous star. It's a star near the end of its life. I said it could go supernova anytime. Could have already blown up. We don't know about it yet. But that's Betelgeuse. Are the stars bigger than Betelgeuse? Yeah, there's a few, but not many. Yeah, question?
How do we know that Betelgeuse is at the end of its life?
By looking at the light that it's giving off. They use a spectroscope to analyze the light, and they can tell from that and from our knowledge of physics and things that this star is.
Hydrogen.
What's that?
There's less hydrogen. I think
Well, it's expanded very big and cooled down. The reason they're called red giants or red supergiants, and that's because the outer shell of the star has cooled down as it's expanded. It's kind of like when you compress things, gas, they heat up. If you let gas expand, it cools down. And so it's got this kind of red color at this stage. But there are a few other stars that we know of that are bigger. The VY Canis Majoris is certainly one of the biggest things, and it's barely able to hold together. It's so big, and it's almost ready to disappear. And look how big it is compared to our sun. So again, here's the little inset here. There's the star. There's a little sun right there. This thing is monstrous. Huge star. Here's a photograph of it. So there's the star right there. And say it's barely holding together. It's throwing off material out into space. We'll go supernova sometime soon, presumably. Soon in the sense of millions of years. It's barely hanging together as a star. It's just so big, and the reactions are going on there are so tough that it's just ready to fall apart. So let's go back to our shallow sky. We talked about stars and things. Let's go back to our solar system for a second. So what's wrong with this picture? Here's a picture. If you go and on the web, you say image solar system and search for it, you'll find this. There's an image of our solar system. Or you'll find this. And the things that are wrong with this, I mean, the sizes of the planets aren't really to scale, as you saw from earlier, but also the distances aren't right. But the problem is this is what you find on the internet all the time. And so you get this bad image of how far apart things are up in our solar system. So the best way I know of to understand this is a model called the Earth as a peppercorn. So what we're going to do is we're going to take our sun and we're going to shrink it down to the size of a soccer ball. Let's put it right there. There's our sun. Hello. There we go. In this scale model now, if that's the size of our sun shrunk down, the Earth would be about the size of a peppercorn. Now, for kids that don't know what a peppercorn is, that's the thing you put in your pepper grinder and grind up. It's about, or a BB is the other thing that's sort of about that same size. It's a little tiny thing about that big. And so that would be the size of the Earth in this scale model. And then the question is, well, where do you put it for the distance? Is the peppercorn, this far away from the sun over there? Is it this far away from the sun? Has anybody got a guess?
Where our car is.
Where the car is? Pretty good guess. So the door, from here to the door, that's about, 17 yards. It's about 26 yards out where you got to put the peppercorn. So you got to walk through that door and walk maybe 50% further out there. And that's where the peppercorn is compared to the sun. So it's like really small and really far out there in this scale model. So in this scale model, the moon around our sun would be a tiny little pinhead about 2.5 inches away from that peppercorn orbiting around out 26 yards away. So the moon's relatively close in this scale model. Pluto is a tiny little grain of sand 1,000 yards away, 10 football fields away is where this little grain of sand is out there. It's amazing that they were able to find this thing in the telescopes. So at this scale, our solar system is about 1.2 miles in diameter. And then the question is, where's the next nearest star? Which I said was Alpha Centauri. Actually, it's Proxima Centauri, but we'll call it Alpha Centauri. Where's that nearest star? How far away do you got to put another star, another soccer ball? Is it over in Denver? Is it down in Texas? Where does that have to be? Well, it turns out you got to put that soccer ball about 4,000 miles away in London, England. Wow. So you've got a soccer ball here. You got a soccer ball in London. Got one down in Chile, maybe one over in China somewhere. That's how far apart stars are up in our galaxy. And that's not, that's the average distance between stars. And things. So it's space is called space because it's mainly empty space up there. It's got a good term for it.
Bill,
Yeah.
can you show them how fast light speed is in this model?
I can show you that. Matter of fact, at this scale, the speed of light. Good. I'm gonna be traveling at the speed of light right now. That's it. I'm going the speed of light in this scale model. So it'll take me 8.5 minutes to walk. 8.5 minutes to walk from there out to where Earth is. Yeah.
If we can see stars out of a telescope in our solar system, then why is the nearest star like 4,400 miles away?
So our solar system doesn't have, the only star in our solar system is our sun. So the other stars are way far away from the sun. So yeah, our solar system is only, let's say, about a mile in the scale, about a mile in diameter. Yet the next nearest star other than our sun is 4,000 miles away. Okay?
Bill, I have a question.
Yes?
Because Pluto is no longer considered a planet,
It's a dwarf planet, yeah.
what is the end of our solar system?
Okay, we're going to get to that. We're getting there in about 2 slides. So here's our current planet lineup. And again, this one doesn't have the distances right. And of course, the reason you can't do the distances right is because you need a piece of paper that's, 1.5 miles across. So they always shrink it up like this. They actually have the sizes pretty well here. And as you can see, yes, Pluto is down here under the dwarf planets. It has been demoted. There is a possibility it's going to get undemoted and turn back into a real planet. They're still debating this. I won't go into it right now on why they did this and why they might not do it. After the talk, if anybody really cares, I can discuss that. But anyway, that's the planet lineup. But there are things beyond Pluto. As John talked about with Ultima Thule, that was from something called the Kuiper Belt. So there's a whole body, the white ring around our solar system there, is objects like Ultima Thule, and there's hundreds of thousands, millions of these things out there that are out beyond that, and that goes out for quite a ways actually. And then they think there might actually be another body of objects called the Oort cloud, way beyond that, like hundreds of times the diameter of our solar system, out further out. It's kind of hypothetical right now; they don't know for sure, but in reality, but those things are all still in orbit around our sun. So yes, it's part of our solar system. So yeah, our solar system is really quite big. We sort of think of, out to the edge of Pluto, that's where it is. But there's a lot of stuff out beyond that that's still under the gravitational pull of our sun. Okay?
So what are those? Are those just rocks or what are they?
So, and we'll get to that in a little bit too. They're balls of ice and dust, which are really comets. Or they will become comets if they get in close to our sun. And we'll get into that. So John, I didn't know John was going to talk about Ultima Thule, so I threw in a slide of it. There's my slide of it. And the size of it, it's about 21 miles in length, just to give you a sense of how big this thing is. But Ultima Thule is one of these objects that's out there in the Kuiper Belt. So after New Horizons flew by Pluto, it continued out into the Kuiper Belt and by one of these big objects and found Ultima Thule. All right, tonight, the moon is going to be beautiful up there. It's a nice first quarter moon, and let me just say a few words about it. So we were talking about the distances and sizes. That's a scale model of how far away the moon is and how big it is compared to the Earth. The moon's about 1/4 the diameter of the Earth. Here's a picture of it. This picture has been a little bit enhanced to make the craters stand out better. But this is what we see if we look at the moon. You'll notice there's two types of surface on the moon. There's kind of this heavily cratered area down here and up here. And then there's these sort of gray areas here. The gray areas are called the mare. Mare is a Latin word for sea, because before they really had good telescopes, they would look up there and they'd see these things. Oh, there's bodies of water up on the moon because it looks smooth and dark, and say, oh, there's oceans and seas up on the moon, and they didn't know then. What we now know is going on here is these things. Notice that most of them are fairly circular and things. They're actually really, really big craters. They're called impact basins, and way back, around 4 billion years ago, soon after our solar system formed. There was a lot of debris up there and some big things slammed into the moon. And what it did is when it did that, it actually fractured the moon. The moon at this stage had started to cool. It had formed a crust around it as it cooled. And so it had a hard surface, but these big asteroids would slam into it and make a big basin, and it would fracture the crust such that the molten lava below it would flow in and kind of fill the hole. And then it solidified. And so you get these kind of smooth areas. This happened after most of the heavy cratering happened. So, that area there used to look like this, but it got a big crater in it, and then it filled in with lava and became smooth. People always ask, where did Apollo 11 land? Apollo 11 landed right there. This is called the Sea of Tranquility, if you'll remember. And they landed right about in that spot there. And again, the first landing they picked because they wanted to find a smooth area. They wanted to land in one of the mare because it looked scary to land in this sort of very rugged spot here. And they said, well, let's pick something smooth. This is a picture of the far side of the moon. Many of you might not know that we never get to see the other side of the moon. We only look at one face of it. And it wasn't until 1959 that the Russians sent a space probe up in here and flew around the back side of the moon and took a picture that we were able to see what this thing looked like. The original 1959 picture wasn't nearly as good as this one, but it had the basic idea. And it's interesting, this looks very different than the other side of the moon, doesn't it? One, there's not very many of those mare that we see. And we think the reason is that when the moon and the Earth system were just soon formed, there was heat coming off of the Earth, and it made the crust on the side that faced the Earth thinner. It didn't solidify as fast, and it was easier to form those mare on that side of the moon. Any questions? Yeah.
I guess my immediate thought would have been if it shields the moon from further craters after Mars cooled. But
that's not the current belief. They've been working on this for a while. I'll also mention the way the moon formed. The way the moon formed was you guys have all heard of the Big Bang. There was something called the Big Whack, and the Big Whack was the Earth formed. It was solidifying out in our solar system, and then some other planet came by. That planet's not in our solar system right now, but it was about the size of Mars, and it made a glancing blow and hit Earth, and it knocked a chunk of Earth off into space. That then went into orbit around Earth and started to solidify, and that became our moon. Our moon's very unusual. It's much bigger than most planets' moons, and it had obviously a different way it formed. Yeah.
I see these like spots that go up, not exactly a crater, and that have craters in it on the backside. What are those?
What are these? Is that what you're asking about?
Kind of like on the right side.
I think he's talking about the other face of the moon.
On the other face of the moon?
No,
On this one?
This side.
I don't know. We'll talk about it later. I'm not sure what you can point it out to me.
I
In the
can
thing.
point it out if you want me to.
Okay. I'm not sure I can answer your question, but you can point it out.
Like right here, reach it.
That thing right there?
I can't reach
The
it.
craters that look like they're pointing out instead of going in.
Yeah, they look like bubbles.
Oh, they were look like a flow.
It looks like they're
I see that.
kind of like dents.
Yeah, that's
That's the crater.
Got it? Okay.
It wasn't a dent, though.
Well, those are all dense. So this is what the moon's going to look like tonight. This is the phase it's in and what you'll see. So again, when you get up there and look at the moon, notice the mare, these dark gray areas. Other things you can notice, that little crater up there is called Plato, after the Greek philosopher. It's also kind of a very small impact basin in a way. And then there's a mountain range here called the Apennine Mountains that you'll notice. That little chain is a chain of mountains along there. Most of these craters, the big craters you see here, are about 70, 80 miles in diameter. So you could put the whole Front Range area inside one of those craters. They're pretty big. If we get up there and look really quick, as soon as the sun, you get out there, Mars is setting right now. So I listed this because it's there. You won't see anything with this kind of detail. What you might see is a little red ball or orangey ball. And maybe you can see a small amount that it's not uniformly red. It's got a little darkness here and there. There are two main moons of Mars, Deimos and Phobos. And then other things in our solar system. I'm going to just go through the things that are in our solar system. So comets, that's another type of object that's in our solar system. We actually had a nice comet that came by this past month that a lot of people went out and looked at. So here's a picture of a comet. This is a comet Ison. There is the sort of bright area here is called the head or the coma of the comet. It's got a tail that goes off here. So I mentioned briefly, comets are thought of as dirty snowballs. If you went out and got some dirt and gravel and sand and snow and kind of packed it all together, that's pretty much what a comet body is. And that's what's out in the Kuiper Belt. It's kind of leftover remnants from our solar system's formation. And so those guys are hanging out there up in the Kuiper Belt, and every once in a while one might drift close to another one and kind of disturb its gravitation, where it is gravitationally, and it'll start to go in toward the sun. And it'll fall into the sun. As it gets close to the sun heats it up. And that ice turns into vapor as it heats up, and it gives off a gas or water vapor. And that's part of what you see streaming behind here, is that material. But I must also mention it's a dirty snowball. It's got gravel and sand and stuff like that packed in there too. That stuff gets released. And so you get this stream of particles stream behind these comets also as they come in toward our solar system. And that'll become interesting in just a second. Here's what one looks like if you got up really close to it, and we actually did. This was from our Rosetta probe. We flew in and we actually sent a probe onto this comet and things. But that's sort of what that dirty snowball looks like. And this thing's, it's huge. I forget the diameter of this thing or the length of it, but it's miles big and things. So that's what a comet is. Meteor showers. So I mentioned all this debris that gets released from the comet as it evaporates, as it comes in. Well, that debris is sitting up there in our solar system, and if our Earth, in its orbit, passes through that trail of debris, all those little grains of sand and rocks and pebbles and things burn up in our atmosphere, and it causes a meteor shower. So when you think about the Perseid meteor shower in August, for example, that's one of a well-known one, that's our Earth hitting the debris that was left behind from a comet that came through in our solar system. And again, we call these things shooting stars. Shooting stars, they're not really stars, but they're really just little grains of sand, pebbles, things like that are burning up in our atmosphere as Earth passes through that debris stream. Okay. Asteroids are another type of object in our solar system. This one's called Gaspra, about 10 miles in length. And again, these are just mainly rocks. So very little ice in these, and they're just rocks. And turns out the asteroids tend to orbit. That's all the yellow guys are asteroids. So here's, we get way up and look down in our solar system. There's the sun, and of course Earth and Mars, next one out. So there's all these asteroids, and there's about almost 750,000 asteroids orbiting around in here, inside between the orbit of Mars and the orbit of Jupiter. There's also a little group of asteroids here and down here that kind of are in the orbit of Jupiter. They kind of precede it and follow it, and those are called the Trojan asteroids. Yeah?
Is there any reason they're all in that ring there? Like, why aren't they just spread further apart there?
Yeah, some people, they used to say that was a planet that didn't form. But it turns out that if you took all the material that's in that thing and packed it together, you'd get a very small planet. I mean, it's not really a failed planet. I don't know the answer to that, really. And I'm not sure anybody really does, why we get all the asteroids in that area. But it turns out the gravity, Jupiter sort of dominates our solar system other than the sun. It's a massive thing, and it's obviously has an effect in keeping these asteroids orbiting around in that area.
Does that pose a danger to spacecraft traveling through that?
Not so much, because there's a lot of space out there. I mean, yeah, they kind of worry about it a bit, but in reality, if you just randomly shot through there, the chances of you hitting something is extremely small, because 750,000 of these things sounds like a lot, but there's a lot of space up there. So there's many hundreds of thousands of miles in between them that you'll just go through. Yeah, John.
Hollywood messes up our picture.
Right. Okay. So deep sky. As I mentioned, deep sky are things out beyond our solar system. So now we're going to talk about stars and things like that. So we'll start with stars, because that's the sort of most fundamental thing out there. This is a picture of Betelgeuse. As I mentioned, this is a red giant star, gotten very big, it's nearing the end of its life. Stars are kind of boring to look at. I mean, it's a little pinpoint of light. Sometimes if you get a star really low down in the sky, it kind of flickers and has different colors, and it's pretty thin. But a star by itself often is not very interesting. But stars do make constellations. Let me say a few words about constellations on the sky. So some of you guys may recognize this constellation. This is Orion. It's in the winter sky. This is Orion's belt. This is Orion's sword. There's Betelgeuse right there. This star is called Rigel. What we tend to do is, most of these constellations at least in our part of the where we see, from where we see them on our side of the Earth. In the southern hemisphere, it's different. But in the northern hemisphere, most of these constellations were kind of made up by the Greeks and the Babylonians, and some by the Romans a long time ago. And what they did is they made pictures up in the sky. And we now draw little lines to kind of help us recognize this. So here's Orion. He's got a sword up here, a shield, and he's holding a sword here. These are his shoulders, and a little head here. It's the belt, I said, and his feet go down here. So we say, well, that's the constellations. It's these stick figures we make up here. Well, on the old star atlases, they actually drew pictures of these things. And that's the picture of Orion up there, slaying this lion in this case, and things. And so that's sort of the mythological figure we're doing here. In reality, a constellation, as we know it in science, is actually just an area of the sky. So they've drawn out the boundaries and say everything within this thing is part of the constellation Orion. And they've kind of tiled the whole sky such that every star is in some constellation, even though it's not part of the picture that we think of. The other thing I'll mention is, if you go back to the picture, the stick figures, you sort of think of all these stars as related. And generally in constellations they're not. They look like they're in the same part of the sky, but one star in that constellation may be 1,000 times closer to us than the other one. So one's way far away, but it happens to be a very bright star, such that they look like they're about the same brightness and next to each other. So they're not really physically related to each other, the stars, except Orion actually is an exception to that, because the stars in Orion actually did start forming together. Yeah.
So who's they? Who defines edges?
The International Astronomical Union does that. I mean, there's a committee, and you've got to have a committee. A committee did.
I was going to say.
Yeah, you got it. You got it. So I said single stars are kind of boring. Double stars are interesting. Double stars, let me back up just a second and say how stars form. So in our galaxy, we have these big clouds of dust and gas. They're called molecular clouds. And they're up there in the spiral arms of our galaxy and just kind of sitting there at equilibrium, not doing much of anything. But every once in a while, something happens to that cloud that disturbs it. And it may be a star nearby goes supernova and sends a shock wave through the cloud. Or it may just be something as simple as some other star migrates through the cloud and the gravity of that star disturbs the cloud. And the cloud starts to kind of fall in on itself and it collapses. And as it does that, gravity takes over and it just sort of pulls the cloud in. But as it does that, it fragments into subclouds. And so you get a whole bunch of little subclouds formed. And they shrink down and sometimes they fragment again. And then eventually, those small little clouds shrink down and become a star. But sometimes, right before that star forms, it splits one last time. And you get two stars that form really close to each other, and they actually orbit around each other, like this. Think of twirling a baton, the tips of a baton. Yeah, you got it. That's what's going on here. This is a star. This is actually in the summer sky. We can't see it tonight, called Albireo. It's a pretty one because it's the color difference between the stars. And double stars are neat to look at, and they're really neat to look at when there's a color difference between them. And hopefully we can show you some tonight. Another type of object we'll look at in the deep sky are star clusters. So I mentioned these big clouds fragment, and you get a lot of subclouds. Each one of those little subclouds eventually forms a star, and you get a whole sprinkling of stars up in space. So here, there's two clusters here. This is called, appropriately, the double cluster. That's a cluster of stars, that's a cluster of stars. All these guys up here are kind of background stars. They're not really part of this object here. But these open star clusters tend to have a couple hundred stars in them, generally. And they might be something like 30 light years in diameter. Here's another star cluster you can see tonight. It's called the Pleiades. A lot of you guys are going to be familiar with this. You can see it naked eye. It happens to be a star cluster that's close enough to us that you can see it naked eye. You think, oh, wow, what's that little grouping of stars up there? Well, that's the Pleiades. It is a star cluster also. There's an object called a globular star clusters. These are really different. Even though they're called star clusters, it's a totally different object than the open star clusters. These guys, rather than have a couple hundred stars, might have 500,000 to 1 million stars in them. They're these balls of stars. They're kind of mysterious. We don't fully understand how they formed or what they're doing there. There's only about 150 of them in our galaxy, which is a very small number of anything. I mean, when you talk about our galaxy, we're talking about 200 billion stars in our galaxy, millions of nebulae and this and that. Why are there only 150 of these balls of stars up there? We don't know. It's an active area of research right now to try to understand exactly what's going on with these guys. Interestingly, if our sun was in a globular cluster, so we were packed in like this, we would never have a dark night sky. You'd go out and our night sky would be filled with stars, maybe about as bright as Venus, when you see Venus really bright up in the sky, maybe even as bright as the moon, all over the night sky, and so it would never really get dark. So yeah, it'd be very different to live inside a globular cluster. Another type of object we'll look at is a nebulae. This is one called the Orion Nebula. We'll look at it tonight. So remember I talked about the star formation, the gas cloud collapsing down. That red stuff is the gas. And the stars that are forming here, there's actually a little, you can't see it very well in this picture. In the telescope you'll see it. There's a group of 4 stars right here called the trapezium. Those are hot young stars that are just being born. And they're energetic. They're like little kids that are just running around giving off all kind of energy. And that energy is illuminating all that gas there and causing it to glow. And that's what a nebula is. It's a glowing cloud of gas. In a few million years, if you came back and look at this thing, if we could, we'd see a star cluster there. So those star clusters I showed earlier, they're what happens after the gas collapses, and then the hot young stars kind of blow the rest of the gas away off into space, and it leaves a star cluster there. So this is the beginnings of a star cluster. Another type of object we'll look at is a planetary nebula. This is at the other end of a star's life. Stars a little bigger than our sun, when they die, they basically blow off the outer shell of their atmosphere off into space, and they leave the core star there. And that core star is very hot and energetic at that stage, and it's giving off high energy radiation that causes all that gas to fluoresce. It's a big fluorescent light tube up in space. And that's what we see. So that's the star right there that's dying. And it's blown off its outer atmosphere off into space and then causing it to glow. So there's a couple of them we can look at tonight. And then I think, well, the next to the last thing I'll talk about on this are supernova remnants. So these are stars that explode. These are stars that are about 8 times as big as our sun, 8 times as massive. The way they die is they can't go out easy by making a planetary nebula that just kind of blows off into space. They become so unstable they just blow up. This is one, again, visible tonight, called the Crab Nebula. This is the remnants of the exploded star. There's actually a pulsar, a really compact flashing object in there because it's flashing because it's spinning really fast. In the center of this guy went off in 1054 AD. The Chinese astronomers, or at least we saw it in 1054 AD. The Chinese astronomers at that time recorded it in their journals. They called it the guest star because it was so bright you could see it during the daytime. There's this big bright object that just appeared in the sky all of a sudden. And they recorded where it was relative to all the other stars in their journals. If we go look there now, we see this. This is the remnants of that star that blew up. And even in the 100 years or so we've been taking pictures of this kind of thing, if we go back and look, we can see it moving out. It's expanding. Just in that 100 years, we can see it in motion. And then the final thing that I'll talk about in deep sky are other galaxies. So everything I've talked about so far is in our galaxy. But there are whole other galaxies out there that some are similar to our galaxy, some are not similar to our galaxy. This is one called M31. It will be visible tonight, although it's going to set pretty soon. This is a spiral galaxy, so we're looking at it kind of angled like that, or maybe angled like that, I guess, and things. Notice that the black stuff there, and there's black stuff here. That's actually those dust clouds I was talking about. That's the stuff that stars form out of in here. And this thing here, that's not a lack of material. There's something here obscuring the stars behind it. It has some companion galaxies. There's a companion galaxy here, one here. Our galaxy has companion galaxies also. It's called the Magellanic Clouds. You can only see them in the southern hemisphere. And this particular one's it's a little bit bigger than our galaxy. And it's part of what's called our local group of galaxies, about 30 galaxies or so that are part of our local group and are kind of clustered together. And I'll mention stars are really spread apart far. So I mentioned the star here, the star down in London, things like that. Galaxies are actually pretty close together relative to their size. So it's like you've got a dinner plate here, maybe a dinner plate here, and one up there. That's about how far apart galaxies are compared to their sizes. Doing okay? Questions? Yes?
Why is it on a slant?
Just happens to be the way where it's oriented, the way we're looking at it. You'll see some other ones we look at that we're looking face on, so you see a real spiral. Some you see edge on. Just the way it's oriented, yeah.
All the galaxies, are there mostly planets in them, or mostly stars?
Good question. Are there planets in these? Yes, so we've only recently, in the past 20 years or so, or even less, have really been able to detect planets around other stars. And what we've learned is that planets are pretty common. We now believe probably most stars have planets around them. And likewise, in other galaxies, those stars probably have planets around them too. So yeah, there's a lot of planets out there and, potentially life around those planets. Yes?
How do scientists come up with the names for planets?
How do scientists come up with the names of planets? A good question. They usually have a theme that either something from Roman mythology. Mars is a god of war in, I think it's Roman mythology. So I think they tend to use Roman names for the planets. For other things like moons, they might use another culture's names, and they'll do things like that. And again, a committee gets together and decides, yes, we're going to do it. And sometimes they vote on it and this and that. Yeah, question?
Is the galaxy technically a rift into other parts of space?
Is it a what?
Rift.
Rift? No. At least not that we know of. No, it's just another gravitationally bound grouping of stars. They're up there. Again, this guy probably has 200 billion stars in it, or something like that. But, it's not a rift in space, whatever. It's not like time travel and things like that when you go through it. It's not a black hole. Although it is the case that most spiral galaxies like this do have a black hole way down in the center of them. So black holes are these areas of space where so much matter has formed that gravity is so strong that light can't get out of that area of space. And our galaxy has one, this galaxy has one, and we believe probably most spiral galaxies have black holes in their centers.
You're going to tell them the other interesting fact about this one?
What's that?
What's going to happen?
Colliding? Yeah, so we've figured out that the two galaxies are moving towards each other. Our galaxy and the Andromeda galaxy, which is M31. They're moving towards each other, and is it 2 trillion years? It's supposed to billion years. 2 billion years or so. They're supposed to collide, perhaps. In reality, again, the stars are so far apart, they'll basically sort of pass through each other. But when they do that, the gravity will, from one thing will pull on the other, so they'll distort each other. And we see that. There's a lot of pictures of galaxies that are called interacting galaxies that you'll see them, they're passing through each other, and it streams out a big stream of stars, so one goes away and it leaves a big trail of stars behind it that kind of pulled off the other galaxy. That'll happen in, a couple billion years.
I don't think we have to worry about it.
We don't have to worry about it, thankfully. Yes?
But it is at a relatively fast rate, astronomically.
Yeah.
About 700,000 miles per hour.
Yeah, they're far away and they're moving fast. Yeah.
If life is still on planet Earth, what'll happen? Will it just die? Or?
So life will not be on planet Earth by that time if our science is correct. We think probably in about, get all my units correct. Well, actually, it's in about another 4.5 billion years. Yeah, 4.5 billion years. Our sun is going to swell up and get very big. And at that stage, the sun will kind of consume the Earth. So yeah, if this actually hits before that, we probably wouldn't notice it, or life on Earth wouldn't notice that when they sort of interpass, go through each other, because again, the stars aren't going to collide, our planets aren't going to collide with anything, and they'll probably pass through each other. But around that time, our sun's going to get really big and swollen, and we'll probably, if humans are around, they probably will have migrated off to colonize other stars and planets and things like that. Yes?
We'll probably all speak there right then. Why is Earth the only planet that has life?
Well, we don't know that. There might be life around lots of planets, and we just don't know yet. And that's
Like on the planets.
yeah. There's scientists that are studying that and trying to find life on other planets. And it's entirely possible, maybe even likely, that there is life on other planets.
Like Mars.
Not planets in our solar system. Well, there might be life. There wouldn't be intelligent life. There wouldn't be people like you and me on Mars. There might be little molds and algae and things like that that are growing on Mars. But okay. So, and my final thing on galaxies is this picture here. This is called a picture called the Hubble Ultra Deep Field. So what they did is they took our Hubble Space Telescope and they found a nondescript area of space that there weren't any stars or anything there, was nothing obvious, and they pointed the Hubble Space Telescope at it, and they took a long exposure. And you know that if you have a camera and you take, in dim light, you got to expose longer to get it to come out. Well, they did something that was about an 8-day exposure here. They left the shutter open, not at one time, but they kind of summed it up and got about 8 days of exposure on this area of the sky. And this is what they saw. Almost everything here is another galaxy. These aren't stars. There are a few little stars. That's a star there, and I think there was a star up here somewhere. There's a star up there. You see the spikes around the star. But all these things are galaxies. Someone added them up and said there's about 10,000 galaxies in that picture. And then the question is, well, how big an area of the sky is that? Are we talking a chunk of sky that big that they exposed? And no, it turns out if you took a drinking straw that was 10 feet long and used it as a telescope, looked up through that 10-foot long straw, that little area of the sky up there you'd see through that thing is that. And there's 10,000 galaxies just in that little area of the sky. So if you think of our whole sky, how many galaxies there are in our universe, it's a lot.
About the size of a grain of sand, Phil?
Grain of sand?
Size-wise?
No, it wouldn't be quite that small, I don't think. Think of something that big. Straws maybe that big in diameter, 10 feet away. That how far, what you'd see.
It's going to be considerably smaller than
Yeah.
your aspect ratio.
No, I agree. It'll be small. It'll be maybe 10 times smaller than that. Maybe it's a grain of sand. A big grain of sand is that. So anyway, it should make us feel very small. We're this little planet Earth around in our galaxy. There's billions of other galaxies out there. Many of them our size and like that out in our universe.
So how deep is that?
This is looking back a good fraction to where the Big Bang. So the Big Bang happened about 13, they argue about it, about 13 billion years ago. I think this might be looking back maybe 10 billion years in time, somewhere around that. So so this is 10 billion light years away is what we're talking about in this case.
This picture is kind of like an ice core sample, right?
Yeah, exactly. Yeah.
There's a few stars in here from our
Right, okay.
So we're getting through the talk here. And I'm a lot of information. There's a textbook on astronomy for you guys. Our Milky Way galaxy, that's where we live. We call it the Milky Way galaxy. And we call it that because that band of light you see up in the night sky, if you get out away from the city lights where you can see the Milky Way, you see a sort of band of glowing light across the sky. And they call that the Milky Way. And those are actually the arms of our galaxy, the spiral arms of our galaxy we're looking at. and we're kind of embedded in them. But anyway, if we could get up outside of our galaxy, way up and look down on it, we would see something similar to this. This is our, at least as a couple of years ago, this is the best rendition that we could come up with. Now, again, this is not a photograph. We've barely sent a space probe out beyond the edge of our solar system, much less get up way above our galaxy to look down on it. But we do think that this is what it looks like. It's called a barred spiral galaxy. The bar is this thing here, and the spiral arms come off the tips of the bar here and spiral around. Earth is about there. Well, that's where the sun is. And again, this is not to scale. Again, the sun would be this microscopic little thing in this, but I drew it really big so you could see it. Yeah?
Why or how does the bar form?
I don't know the answer to that. And I don't know whether we really understand, if people that study galaxies really understand that either. Yes?
Are there any more planets inside the galaxy that we know of?
Yes. We know of a lot of galaxies. We've discovered thousands of planets by now around other stars. Again, this is just in the past 5 years or so we really figured this out, how to find these planets. Didn't have the technology to do it before that. Any questions? So that's the face-on view. If you could turn on an edge, you'd see something like that. And again, that looks a little bit like that other galaxy, the Andromeda galaxy I showed earlier. This is just edge on. And again, all that dark stuff there, that's the gas clouds, dust and gas clouds inside the spiral arms that could collapse and form new stars and things. And again, it's got a core here, kind of galactic bulge. So a few facts about our Milky Way. It's about 100,000 light years from one edge to the other edge. So again, we're talking, when I said star, the nearest star to us is about 4 light years away from us. It's 100,000 light years from one edge over to here. Again, remember, we're right about here in this picture. It contains approximately 200 billion stars, we believe. We can't count them, but we can estimate it. The mass of it's uncertain. It contains about 200 billion solar masses. Half of it's going to be in stars, half of it in dust. And it's given off enough light, the same amount of light as about 10 billion times that of the sun. So, I mentioned 200 billion stars. Again, that's a number, it's hard to think of what 200 billion stars is. A lot of stars. But, another model. If you shrink the sun down to the size of a grain of salt, turns out that a box of molten salt, those are those boxes that kind of round like that, about that tall, they contain about 1 million grains of salt in one of those boxes of salt. So if you do the math and ask, well, how many boxes of molten salt do we need to represent every star in our galaxy? You need 200,000 boxes of salt to represent every star in our galaxy. It's a lot of salt. The average distance between the grains of salt would be about 7 miles between each other. So again, it's a lot of salt, but they're spread out a lot. As I say, stars are not packed into our galaxy the way it looks like when you see a picture. There's a lot of space in between them. All right, so we're almost getting toward the end here. Let me briefly talk about equipment. So hopefully I've piqued your interest a little bit. You say, I want to see some of this stuff, and you'll see some tonight. But let's talk briefly about equipment. It used to be that when we told people how you learn the night sky, you'd say, oh, get a planisphere. I always found these things immensely frustrating. They're these little pieces of plastic or cardboard that you kind of rotate a couple dials around. One of them you set what the time of year it is. It's got December, November, October. You have to set one thing to be the month, and then the time of day is on the inner thing. So you'd say at 12 o'clock on August 5th here, that's what the sky is going to look like and things. And it doesn't have much detail, and yeah, you can recognize the bright stars, but it was hard to use, very frustrating. Throw those things away. Nowadays, you get an astronomy app. You just get an astronomy app. Trust me, trust me. As we said, I write one of these things. I'm biased, of course. This is a picture from SkySafari running on an iPad. It's got all the detail you want. You can tap on any object in here, bring up some information that tells you all about it. You can learn about how far away it is, how big it is, you know, what it's doing there. There's little essays about this stuff in here. You can run it backwards and forwards in time to see what's going to look like when I go on vacation in 3 months, you know, what's going to be in the sky then. You can zoom in and see, you know, faint little galaxies and stuff like that. So this is the way you want to learn it. Now, SkySafari is my app. There's other apps out there that are good too. I won't deny that. Our app tends to be more scientific than a lot of the popular apps out there. We designed it for amateur astronomers primarily, but it's also great for people who are just sort of casually interested in the sky. Other things people use to learn the sky, they'll have an atlas of the night sky, again, paper atlas. This is an example of something called the Bright Star Atlas. Again, it's got the stars. There's Orion right here, the 3 belt stars. There's Betelgeuse, Rigel. And here, though, you can't see it in this picture, but there's all kind of things plotted here, like little star clusters and galaxies and things like that. And so it'll tell you, oh, if I take my telescope and I point it between these 2 stars, I'll see this galaxy here. And that's the way you find things, or the way you used to find things. There are better ways now. But anyway, you can get star atlases. A piece of equipment you're going to need is a red flashlight. They make commercial ones that you can get that just have a red LED in it. And the reason you want red light is because that doesn't disturb your dark adaptation as much as white light. And that's really critical because we're looking at dim things and we need to be able to, you know, see them. And think about, you know, you're at night, you're in bed, you say, oh man, I got to get up and get a drink of water. When you first get out of bed, you say, okay, I can kind of see my way around here. Yeah, so there's that chair there. And you walk out and you get a drink of water and you turn on a light switch first and you go, oh man, that's bright. You turn it off, you can't see anything anymore. It's like you're blind. And that's what happens when you use a white flashlight. It really hurts your ability to see these dim objects you're looking at through telescopes. So you want to get a red flash. You don't need to buy a commercial. You get red cellophane and put it around your regular flashlight. That works reasonably well. Get yourself a pair of binoculars to start out with. It doesn't have to be an astronomical binoculars. Any pair of binoculars will give you a nice view of the night sky, much better than naked eye. So if you get an astronomy app and a pair of binoculars, you can find all kind of stuff up in the night sky. But you got to get away from the city lights. Get out to some dark sky somewhere. Comfortable chair is nice. Particularly with binoculars, I guarantee you, if you sit there and do that for, you know, about 2 minutes, your neck gets really stiff, or at least if you're my age, your neck gets really stiff. If you have a chair you can lean back in to look at the night sky, it really helps. For telescopes, there are 3 types of telescopes I'll talk about here. A refracting telescope, and we've got one up on the scope up here, is what most people think of as a telescope. It's got a lens in the front. It focuses the light down, and you put either an eyepiece, or here they got a camera here that are taking an image. This mount is set up where it tracks as the Earth turns or rotates during the day. The mount goes in the opposite direction, so it keeps the star that you've centered in the eyepiece, it keeps it centered in the eyepiece. Otherwise, it's going to drift out of the eyepiece as the Earth turns. So that's a refracting telescope. Reflecting telescopes look something like this often. Here, there's not a lens up here at all. You can take your arm and stick it right down that tube. But there's a mirror down here, and it's a very shallow concave mirror, like I think of a makeup mirror that you might use. But the light comes down there, hits that mirror, and then that mirror focuses the light back up to another mirror that's mounted inside right here that turns the light out to the side, and then you put an eyepiece here and look at it. And then there's kind of a combination telescope called a Schmidt-Cassegrain. It's sort of a combination of a refractor and a reflecting scope. It does have a lens here. It's a very weak lens in the front. It's got a mirror back in here. Here the light comes down through here, hits that mirror, goes back up here, hits another mirror here, comes back down through a hole in that mirror, and then out here we can look at it. People like these because they're nice and short, because the light kind of bounces back and forth inside the scope, and you can keep them short, and so you can throw it in your car easily to get out to dark skies. Whereas some of these big Newtonians or even big refractors are hard to fit inside your car because they're long. I will say, if you are interested in getting a scope, don't go to Walmart and buy a scope. I guarantee it'll end up in the closet. They're just not good enough to, they're shaky mounts and they're frustrating to use. There are much better ways to get scopes, which I'll talk about in just a second. What's the most important piece of equipment you can get for doing astronomy? It's your eyes. Take care of your eyes. Wear sunglasses, things like that. So, last subject, and I'm done. Getting involved. How do you get involved in this hobby? So there's a number of local astronomy clubs that you can get if you just, depending on what city or what area you live in, just go on the web and do a web search for, Boulder Astronomy, Longmont Astronomy, Fort Collins Astronomy, Denver Astronomy. You'll find these websites. They're clubs, amateur astronomers that, get into this, and they go out and have, they call them star parties, where they go out to dark skies with telescopes and they look at stuff and share
Bill,
views.
before you finish that slide, I got a question for the kids here.
Okay.
How do you kids live in the Loveland Berkeley area? So there's another way to get involved, though, is if you live in the Thompson School District, you can attend a night astronomy class that's conducted here.
And mommy stuff?
You gotta negotiate that with your community instructor. But, I mean, that's another way to get involved up there. And I'm not sure, Mike, if they can come in through outside of the school district or not. I mean, I know we kind of.
I don't know,
Open enrollment.
but it is for the whole school district.
Yeah, it's for the whole school district, but,
Okay.
there are other ways to do it though, too. But that's one way if you're local to the area, though, too.
Great.
If you're interested in the hobby.
So yeah, find a local astronomy club, and they usually have monthly meetings and different events you can attend and things like that. There are public star parties you can go to. Boulder County Parks and Open Space, my Longmont club has just started partnering with Boulder County to do a monthly star party around first quarter moon. Not our first one, but our second one is tomorrow at Rabbit Mountain. And so we'll be out there with telescopes set up that you can look through a variety of telescopes. If you don't get enough tonight looking through telescopes, you can come out there tomorrow night. It's supposed to be clear. Again, if you go to the Boulder County Parks and Open Space website, you can see the schedule of all the star parties. Rocky Mountain National Park has events up there throughout the summer months. They're mainly for guests of the park, but if you can get into the park, you can go attend those. Again, go to their website and you can find out when these things happen. They're generally a couple a month throughout the summer months. Sandstone Ranch, east of Longmont, often has star parties a couple times a year that the Longmont Club helps with. And then the Northern Colorado, up in Astronomical Society up in Fort Collins, does a lot of public outreach up there. If you live up in Loveland area or Fort Collins area, go to it's called nocoastro.org. But just search for Fort Collins Astronomy and you'll find them. They do a bunch of events. They do 7 events a month or something like that at various parks and things like that. That's another great way to kind of go out there and get some experience. And then finally, of course, I'll mention Little Thompson Observatory. Anybody here can reserve a night for the scopes. It could be just you yourself and some friends. It doesn't have to be a big group. But you just need to go onto our calendar and say, oh, here's a blank night that nobody's there. I'll reserve that. And we'll have volunteers come out here and show you stuff. So that's another option for you. If you don't have a telescope and you want to play with a telescope, we have donated a bunch of small little scopes like this to a number of libraries. So you can go to the Longmont Library. There's 5 scopes there. Louisville, High Plains Regional Libraries, and Broomfield. We've donated scopes to. So if you can go there, you can check out the scope for a couple weeks and take it home. It's got a little instruction manual, and you can play using the scope and see if it's interesting to you. These guys are nice scopes. It's good quality equipment. They won't frustrate you the way your Walmart telescope will. And I think that's it. So I want you guys to think big and keep looking up. Are there any other questions?
So for those that didn't get one tonight, there's brochures for Little Thompson Observatory over here. And it tells you what you need to know about the observatory and how to stay on your own time if you want to know. less long than the
For your information, the Stargazer Observatory in Fort Collins, which is by about a block east of Costa Mesa High School, has open house third Saturday of every month, so tomorrow night is the
Okay. So that's another option. Yeah, there's a little observatory up in Fort Collins that you can go attend and things. So let's go look at these telescopes and see what this clear sky has to show.